Ionic bonds occur between a positive ion, called a cation, and a negative ion, called an anion, because of the electrostatic attraction between the opposite charges. An ionic substance is referred to as a salt. The cation is usually a metallic ion. A common exception, though, is the polyatomic ion ammonium, which is good to know. The anion is a non-metal and could be a polyatomic ion also, such as sulfate or nitrate. When a metal is reacted with a non-metal, the new substance will be held together with ionic bonds. Let's look at the reaction between sodium and chlorine. It'd be worth having a periodic table with you for this. So I'm going to draw these diagrams to represent a sodium atom and a chlorine atom. Sodium is in group 1, period 3, and it's element number 11. So it has 11 protons and 11 electrons. 2 go in the first level, 8 in the next, and that leaves 1 valence electron in the third level. Chlorine is in group 7 of period 3 and is element number 17. So I draw in its electrons, and it has 7 valence electrons. I'm ignoring the fact that chlorine's actually a covalent molecule for the moment. We just want to look at what happens to the individual atoms. Now, recall that it's energetically stable for an atom to have a full outer shell, like a noble gas, and neither of these two do. Sodium has one too many, and chlorine has one too few. So, if the very electronegative chlorine takes an electron from the less electronegative sodium, they'll both be happy. And what does this do to the overall charge of the atom? Sodium now has 1 fewer electron than protons, giving it a charge of +1. And the chlorine, now called chloride, has 1 more electron than protons, giving it a charge of -1. Each atom has become an ion with its preferred valence. Notice that the sodium has become smaller, its outer shell is now the second level, and the chloride has become slightly bigger because it has an extra electron. The final thing that happens is that the positive charge of the sodium ion and the negative charge of the chloride ion attract one another, and we have an ionic bond. Notice that exactly 1 electron was lost by the sodium and 1 was gained by the chlorine, meaning they have the same charge, and that means the ratio of ions in the final compound is 1:1. Because it's only the valence electrons that we're interested in, we can redraw those rather cumbersome atom diagrams in shorthand, only showing the valence electrons. So let's do another example with magnesium and fluorine. Magnesium is in group 2, so it has 2 valence electrons. And fluorine is in group 7, so it has 7 valence electrons. In order to attain a full outer shell, the magnesium needs to lose 2 electrons, but the fluorine atom only needs to gain 1. What will happen to the second electron from the magnesium? Well, it can be taken up by a second fluorine atom. So, the magnesium becomes a magnesium ion with a charge of +2, and the 2 fluorine atoms become fluoride ions, each with a charge of -1. And that's why the overall formula of this salt is MgF2. So, ionic bonding occurs when a metal reacts with a non-metal. However, it can also occur when 2 existing ions come into proximity, such as when they're mixed in water. Many salts are highly soluble in water, which means the ions separate among the water molecules. But take silver chloride, which is an insoluble salt. If silver ions meet chloride ions in solution, they'll begin to stick together to form ionic bonds, which will create macroscopic particles which are visible as a solid precipitate. We can represent this by an equation called an ionic equation, where we show the individual ions coming together to form an ionic compound. In this video, which was produced by the VisChem project, you have a solution of water, the water molecules are red and white, containing pale purple silver ions and green chloride ions. You can see that as the oppositely charged ions meet each other, they stick together, that is, they're forming ionic bonds, and they begin to form a crystal. When the crystal gets large enough, it will be visible to the naked eye. Notice that the water molecules, which have no charge, don't participate in the ionic bonding. In this task, I'd like you to have a look at these 2 reactions and I want you to figure out what salt would be produced when these two elements react. So name the product of the reaction, then write out the balanced formula equation for that reaction. And then finally, like we did earlier in the video, draw some simple dot diagrams that show how the valence electrons are transferred between one reactant and the other to make the ions of the final product.